All right, guys, we are going over function analysis, and I went ahead. This table is completely empty in your OneNote and in your Desmos, but I filled it out here. And this is kind of the calculus explanation that they're looking for when we're asking about all these key features of a function. So we know that function f is increasing when f prime is greater than 0. That means our derivative is positive, and then it's decreasing when our derivative is less than 0. And if you think about it, that makes sense because derivative is slope. And then we have relative maximums and mins when that first derivative changes from positive to negative. So just kind of as a reminder, if you had f prime of x, and let's say I had factored and done all the things, and I got x squared, and then I got an x plus 3, you have two solutions here, right? You have a 0 and a negative 3. This 0 is not going to be a max or min because it has a double multiplicity, which means that that function is bouncing, right? It's not changing signs at that point. So if we were to think about that, just following through, you would have that negative 3 and that 0 as solutions. And this is cubic and positive. So the end behavior, it starts low, ends high. It would cross through negative 3 and bounce at 0. You can always make a sign chart, right? And you're like, I'm going to plug in values. Like I'm going to plug in a negative 4 and see that that is a negative. And then I'm going to plug in negative 2 and see that that's a positive. And then a 1 and see that that's a positive. So there's no sign change happening at that 0 either way. So just something to keep in mind. Remember that concavity deals with, so increasing, decreasing, max and mins deal with the first derivative, and then concavity deals with the second derivative. Remember that it is concave up if f double prime is greater than 0, but a point of inflection only happens when that concavity changes. So just like relative mins and max happen when that first derivative changes signs, similar to that second derivative, that point of inflection, so that f double prime has to be changing signs.
All right, so two multiple choice from this unit are going to be kind of like looking at those same ideas. So our first one says the graph of f prime, the derivative is shown above. I always like to kind of like write this larger because so many times we just like to look at it and be like, okay, that's function f. So maybe make sure it's like really big that you're saying, okay, this is the derivative. Which of the following statements is true? Now, I know from earlier when I looked that the derivative tells us if it's increasing or decreasing. So I'm just going to write that down over here to the side. Remember, f prime of x is greater than 0, it's increasing. F prime of x is less than 0, then it's decreasing. So it looks like I'm going to highlight in green. We are positive all the way to 0, so that means we're increasing. And then we are negative all the way from 0 to 2. So we just need to find a statement that matches that. So we are increasing from, what is that, negative 2 to 0, decreasing from 0 to 2. So this first guy says it's decreasing from negative 1 to, well, that's not correct because we have some positive intervals in there. Increasing from negative 2 to 0. Okay. Feels right. Okay, positive. Increasing from 1 to 2, we know that that is not correct because the derivative is negative. Even though that looks like it's going up, that would be looking at more of like that double derivative. A local minimum at x equals 0. Okay, well, we know a minimum happens when we go from decreasing to increasing. This is the opposite. This is actually going to be a max because we are going from positive to negative or increasing to decreasing. So that's a maximum right there. And then it's not differentiable at negative 1 and 1. Well, this is the derivative, and the derivative has a value right here. It's not double differentiable, but it still is differentiable. We have no idea about that. So there we go. It should be b. The function is increasing from negative 2 to 0. Next guy here. Let f be the function with the derivative given by f prime equals x squared minus 2 over x. On which of the following intervals Is f decreasing? Cool. So we're looking at this guy and saying we need to figure out where does f prime of x equals 0, and then we're going to use that number line test to figure that out. So first off, let's figure out some solutions. So let's say 0 equals x squared minus 2 over x. Move that over. So let's say 2 over x equals x squared. 2 equals x cubed. So x is going to be the cubed root of 2. All right, there's my 0. And if we moved that over, right, so if we said 0 equals x cubed minus 2, we know that that's an odd multiplicity, so it crosses. We talked about this just a second ago earlier on in the video. Remember that, like, thinking about what's happening here, like if it's cubic, right, we're going to cross if this guy, well, it's actually raised to the power of 1, so we're good. But just making sure when we are looking at those values, we're checking that multiplicity of not just the x, but the entire factor. So we know that that solution is going to be the cubed root of 2. And then I'm just going to plug in a value to the left and to the right of that. Let's just do something easy. Let's do like a 1, because we know that 1 is going to be less than the cubed root of 2, because 1 cubed is just 1. Right? So if I plug a 1 in, 1 squared, 1 minus 2, that's going to be a negative value. And then if I grab my other guy, so let's do something to the right. Let's positive 2. We know that's going to be greater. 2 squared is 4. 4 minus 1 is 3, so that's a positive value. So we're looking for decreasing, right? So that means it needs to be values that are less than that cubed root of 2. We also have a domain restriction here. X cannot equal 0. So that's also something to keep in mind. There's also going to be kind of like a boundary here at 0. That's an undefined. So when I look at that, and we can actually plug in a negative 1. That's a good thing to plug in. Negative 1 squared is 1. 1 plus 2 is 3, so it's positive here. So it's actually only negative between 0 and the cubed root of 2, which matches D. So we are decreasing.